What if you get up from the sleep and hear there will be no internet in this earth from today? Not for 1 or 2 days, but for a whole month. This news might come as a big shock to some mega e-commerce owner, business magnate and freelancers. But it's better we know the truth as soon as possible so we can take preparation and things still stay bearable for us. Get ready to explore the internet apocalypse and NASA's mission to stop the Canyon of Fire. To get a clear idea about the situation, we need to move to the origin of this thing, to the Sun. Our forever known Sun is a massive, luminous ball of plasma and gas, primarily composed of hydrogen and helium. It is the star at the center of our solar system and provides the energy that sustains life on Earth. Approximately 75% of the Sun's mass is hydrogen, which gets converted into helium through nuclear fusion in the Sun's core. This fusion process releases a tremendous amount of energy in the form of light and heat. The remaining 25% of the Sun's mass is predominantly helium, with trace amounts of other elements such as oxygen, carbon, neon, and iron. The Sun's magnetic field plays a crucial role in shaping the solar system's space weather and driving various solar phenomena. The magnetic field is generated by the motion of plasma within the Sun's interior, a process known as the solar dynamo. The solar dynamo is primarily driven by the differential rotation of the Sun, which means that different parts of the Sun rotate at different speeds. The equator rotates faster than the poles, and this difference causes the solar plasma to move in complex patterns. As the plasma moves, it carries with it the Sun's magnetic field lines, stretching and twisting them. Over time, this leads to the buildup of magnetic energy, which can eventually be released in the form of solar flares and coronal mass ejections, CMEs. The Sun's magnetic field is not uniform. It has a complex structure with varying strengths and orientations across its surface. The field is strongest in areas called sunspots, which appear as dark spots on the solar surface. Sunspots are regions of intense magnetic activity and are often the sites of solar flares and CMEs. But did you know that the Sun's magnetic field goes through an incredible cycle of activity that lasts around 11 years? It's true. This cycle is known as the solar cycle. During this cycle, the Sun's magnetic field changes polarity, with the north and south magnetic poles swapping places. This cycle is closely related to the number of sunspots and the overall level of solar activity, with periods of high activity known as solar maximum and low activity known as solar minimum. The Sun's magnetic field extends far beyond its visible surface, reaching out into the solar system and shaping the interplanetary magnetic field known as IMF. The solar wind, a continuous flow of charged particles, mostly electrons and protons, emitted by the Sun, carries the IMF throughout the solar system. The interaction between the solar wind and Earth's magnetic field creates a protective bubble called the magnetosphere, which shields our planet from much of the Sun's harmful radiation and energetic particles. Right now, we find ourselves in the midst of solar cycle 25, which began in late 2019. But something remarkable happened recently. A sunspot called AR 3089 became unstable and erupted, creating what scientists are calling a canyon of fire on the Sun's surface. But what does this mean for us? Well, now it's time to talk about coronal mass ejections, or CMEs. Coronal mass ejections, CMEs, are massive eruptions of plasma and magnetic field from the Sun's corona, which is the outermost layer of its atmosphere. CMEs are one of the most energetic phenomena in our solar system and can release billions of tons of solar material into space at speeds reaching several million miles per hour. CMEs are often associated with solar flares, which are intense bursts of radiation that occur when magnetic energy built up in the Sun's atmosphere is suddenly released. However, CMEs and solar flares are distinct phenomena. While solar flares involve the release of radiation across the electromagnetic spectrum, CMEs involve the ejection of massive amounts of plasma and magnetic field into space. When a CME is directed towards Earth, it can cause geomagnetic storms as the ejected solar material interacts with Earth's magnetosphere. These storms can have various effects on our planet and its technological infrastructure, including auroras. The interaction between the CME's charged particles and Earth's magnetic field can cause the beautiful displays of light known as auroras, visible near the poles as the aurora borealis, northern lights, and aurora australis, southern lights. Satellite disruptions. CMEs can cause changes in Earth's radiation belts, potentially damaging satellites, disrupting communication systems, and causing errors in GPS navigation. Power grid disturbances. Geomagnetically induced currents can flow through power lines, transformers, and other electrical infrastructure, leading to voltage fluctuations, equipment damage, and even widespread blackouts in extreme cases. Spacecraft hazards. The increased radiation levels from a CME can pose a risk to astronauts and spacecraft operating in Earth's orbit, particularly those outside the protection of the magnetosphere, such as missions to the Moon or Mars. To mitigate the potential impacts of CMEs, scientists continuously monitor the Sun's activity using ground-based observatories and space-based missions like the Solar and Heliospheric Observatory, SOHO, and the Solar Dynamics Observatory, SDO. These observations help provide early warnings of incoming CMEs, allowing for necessary precautions to be taken to protect satellites, power grids, and other critical infrastructure. In the past few days, multiple solar flares have hit Earth, intense bursts of radiation that can wreak havoc on our communication networks. The impact so far has been minor, but more solar activity is expected as solar cycle 25 continues. So, how can we prepare for the potential impact of a coronal mass ejection? Power companies and critical infrastructure providers take steps to safeguard their systems, including surge protectors and other measures. But what about the internet? The internet relies on a complex infrastructure of cables, servers, routers, and power sources. Any disruption to this infrastructure can have significant consequences. But fear not. NASA's Parker Solar Probe, our trusty space explorer, is on the case. It recently achieved a major milestone by navigating through the Sun's solar wind, gathering essential information about the Sun's workings. In the face of a potential internet apocalypse, we must take a multifaceted approach. Backup power, redundant systems, cybersecurity measures, international cooperation, and public education are all crucial elements in our preparedness. So, let's stay informed, be proactive, and work together to ensure the internet remains the reliable and essential resource we rely on every day. Remember, when it comes to the internet apocalypse, knowledge and preparation are our greatest allies. If you found this information helpful, don't forget to like, subscribe, and hit that notification bell. Watch our other video on NASA and SpaceX collaborate to boost International Space Station's energy efficiency. Until next time, stay connected and stay curious.